Hi. It's going to be a follow-up discussion, I believe, because I'm using UTXOs to split in any case. This is a paper written by me, Harsh Patel, and Ankit Malik. And we are going to discuss scaling Bitcoin specifically. My name is Kazım. I'm a PhD student in Bogazici University. I mostly work on blockchain and IoT integration, also a bit of consensus protocols, and I'm also an entrepreneur. So today we are discussing on-chain scaling, but on-chain scaling is easy, right? If we make Bitcoin blocks 1 gigabyte, then we have no problem. We almost catch the transaction throughput of Visa. But we all know that that's not the case. We have to keep the network decentralized also. We have to take care of it. So if we look at it, the bandwidth requirements of running a full Bitcoin node is actually a bit high. It's 400 kilobit per second upload, and you need to have at least 700 kilobit per second total bandwidth in order to achieve a maximum of 7 transactions per second. So if we think that, okay, Visa has 2,000 transactions per second, and in order to achieve that transaction throughput, we have to have 200 megabit per second connections, which is very high. So will the future of full node in the data center? And well, storage is like that. Bitcoin is at 190 gigabyte right now. It's growing over 1 gigabyte per week. And if we consider full blocks, full SegWit blocks, then it's going to increase 4 gigabytes per week. And it's also it's going to require a lot of storage in the future. So is there hope? I'm going to give you a quick summary. So what we are trying to achieve here is we want to create multiple blocks in the same block interval for Bitcoin by creating multiple subchains. And we are going to introduce another chain called eigenchain, which keeps track of the subchain headers. And we are also going to introduce a new type of Bitcoin node called half node, which enables a user to track a subchain and an eigenchain instead of getting all the blockchain block messages. So in order to do that, we have to look a bit deep into UTXOs. As you know, Bitcoin transactions are consisting of inputs and outputs. In order to make a transaction, you have to reference a previously sent money, a previously sent transaction to you. So currently, the first session of the previous day was talking heavily about UTXOs. So currently, there are 57 million UTXOs, and a good amount of them are dust right now. So basically, this is the implementation, right? There are 3 classes, and the most important class, in my opinion, is the CTX out, which is the transaction output. And the most important part there is ScriptPopKey, which defines where we are sending our money. So these are the mostly widely used 2 types of ScriptPopKey. These are the scripts, and PopKey hash, you see, is basically your address. And the script hash is also the hash of your script. And these 2 types of ScriptPopKeys are consisting 90% of the total Bitcoin transactions. So after that pre-knowledge, is there hope? So we divide the UTXO set by calculating hashes of them, calculating the hash of the ScriptPopKey. So if you have one address and you got a lot of transactions sent to that specific address, all the hash values of these transaction outputs will be the same. So we calculate hash values for all the unspent transactions, and then we are going to divide them. There are a couple of strategies to divide these UTXO hashes. You can start by accumulating the amount of Bitcoin. And if you reach the half of the Bitcoin in circulation, then you may say that this is the threshold. Before that will be the Bitcoin number 1, and after that will be the Bitcoin number 2. So we are effectively dividing the spendable money into two separate groups. And by doing that, we are actually dividing the chain state DB, which is the actual database that Bitcoin implementation uses to keep track of UTXOs. And also we are dividing mempool, which also listens, which is the pool of transactions that nodes receive. So every subchain will accept only a subset of UTXOs, only a subset of transactions, and we effectively have chain state 1 dB, chain state 2 dB, and mempool 1 and mempool 2. So throughput will be increased because in one block interval, now you are able to create multiple blocks, and they will not clash with each other. They don't have to query anything to each other because UTXOs are already separated. So you have an account on all the subchains, effectively also. No cross subchain transaction possible. We are going to revisit that. Let's say that it is now. So what is the mining going to look like? Well, we are not addressing mining pools. The mining will be relatively the same. The miners should create blocks for all the subchain plus one block for eigenchain, which should contain the hashes of these subchain blocks. So mining will be a monolithic big thing still. They have to calculate everything, and the eigenchain will actually encapsulate all the information, all the hash values of these specific subchain blocks. The actual difficulty level will be determined by the eigenchain. So there will be proof of work for subchain blocks, but it will be relatively very, very low. So what the network is going to look like. So now we are able to actually partition the network. So we have full nodes. Miners are also full nodes because they have to listen to all mempool messages, because they have to create subchain blocks for all the subchains. So full blocks are sending messages, complete block messages among each other. So they are sending the complete thing. But their subchain networks only receive the required subchain block plus eigenchain. So it's possible to actually conserve bandwidth there because full nodes are not going to send the whole block message there. And all the subchain networks are able to independently verify because they have a subset of UTXOs. So it's possible to work independently. The subchain nodes will relay messages to full nodes also. And one of the problems that is going to arise at this stage is if you don't have enough money in a specific subchain to send to another peer, but your total balance is very sufficient for it, you have to make multiple transactions on subchains. So in order to achieve that in a secure and successful manner, you have to use hash time lock contracts. So you have to create a data, have the hash of it, use that hash to send your transactions, and in the end, you're going to reveal the actual data to your merchant or to your peer, so he can able to cash out. And if all the transactions are not happening in a timely manner on all the subchains, then of course this money will be claimed by you again, so you are not going to lose anything. So this is one of the mechanisms that should be taken care of. But this can be, all these things can be taken care of by wallet implementations. So it can be relatively not transparent to user. So if we compare, we talked about Bitcoin NG a bit. So there is SegWit, there is this failed SegWit 2x, which is only block size increase. And there is Bitcoin NG. As said in Bitcoin NG, there are key blocks that miners introduce, and then there's a 10-second microblock interval. This leader the party that introduced the key block is able to create microblocks, which, as a result, increases the throughput very highly, but it doesn't help you conserve any bandwidth or storage. With split scale, in terms of miners, you have to do the whole mining. You are not allowed to mine a specific subchain in order to, of course, for security reasons. And basically, full nodes will receive the big blocks, so they are also unable to conserve anything. But the half nodes will only receive the specific subchain and the eigenchain, so their storage requirements will be relatively low. Of course, full nodes will store everything, like in regular Bitcoin. And the bandwidth requirements will also decrease for half nodes because they are only getting block dash and the specific subchain block messages. So they are able to conserve bandwidth, and they are able to safely check transactions, and they are able to make transactions in a secure manner. So to sum up, what we are trying to achieve is we want to increase the throughput by giving the option to create multiple blocks in the same block interval by separating the UTXO set. And this new type of Bitcoin node, half nodes, makes it possible to run in a bandwidth constrained environments. So thank you very much.
Thank you, Kazım. That was very interesting. Do we have any questions from the audience for Kazım? We have a question here. Great.
Hi, thanks for your talk. I was wondering, like, how to decide or to restrict miners to mine on all chains and not on specific chains.
The only the only option is just broadcasting the block message. If they don't broadcast the block message, they don't get anything.
But as an adversary, I can just like mine on one of the subchains.
Okay.
To do that, and
you have to also mine.
There.
You have to also create an eigenchain block, which is the actual difficulty. So you have to mine the eigenchain block also, not the only subchain.
Maybe some honest node mines that for me, and includes the reference to my chain. Like, I'm not getting how this works. So how do I pick the chain I mine, or what I can do as an adversary to select and selectively mine only particular chains?
If you selectively mine a particular chain, you have a header, block header for a chain. You don't have the other ones. Then you just fill it with garbage data, okay? Then the collective hash of these headers should be also lower than a difficulty value, which is the actual mining operation, actually. That's what you didn't do. So you are unable to broadcast a valid block message to the network. So you are unable to mine on a specific subchain, actually, because I can explain it.
Yeah. We take it offline. Yeah.
Yeah. The part is the eigenchain. Eigenchain stores the hash values of the subchain block headers. Okay. And this is the part. This is the difficulty thing. This is the actual proof of work there. So you have to create the eigenchain block. All right. We'll talk. Okay.
Excellent. Were there any further questions at this stage? We have a question here.
Okay, no, man. you already know the old UTXO. Okay.
Yeah, I wanted to ask about how bad does the hash time lock transactions, how do they affect the throughput?
In terms of latency, or in
terms of you now need to have some kind of synchrony to make sure that you move the
Yes, the reason that we had to use hash time lock contract is we are not 100% sure whether these multiple transactions are mined. But hash time HTLCs gives us the capability that if they are not mined, for example, in a 10 block interval, I can claim back the money. I can get the money back. So, as a sender,
I'll ask you about that later. Okay, thank
it's
you.
not wasted, so it's not lost.
Were there any further questions for Kazım? If not, then we will go to our next speaker.
Thank you.
Thank you, Kazım.